A race car driver has a pit stop to refuel. After refueling, he leaves the pit area with an acceleration whose magnitude is 6.0 meters per second squared, and after 4 seconds, he enters the main speedway. At the same instant, another race car that is on the speedway and traveling at a constant speed of 70 meters per second overtakes and passes the entering car. If the entering car maintains its acceleration, how much time is required for it to catch the other car, and how far has the other car traveled during the time calculated part A? Okay, so we've got two cars, one of which is accelerating and one of which is moving at a constant speed. And the question is, how much time does it take before they pass each other, collect? Like they're going in the same direction, right? Okay, so basically the Fred and Barney kind of question. Let's read it again and let's identify some things here. A race car driver has made a pit stop to refuel. After refueling, he leaves the pit area. What is his initial velocity for that time? 0. His initial velocity is 0. His acceleration is 6. After 4 seconds, he enters the main speedway. T is 4. Now, what time? That's the time it takes him to go from stop to he gets into the main roadway, right? Like, you guys understand what's happening here? The car's in here, here's the racetrack, and he's doing what? He's entering the main racetrack. How long does that take? 4 seconds. Okay? Meanwhile, there's another guy driving by. The same instant, another race car. The same instant as what? That he enters the speedway. Not the same instant that he leaves the pit area. At the same instant, another race car that is on the speedway and traveling at a constant speed of 70 meters per second overtakes and passes the entering car. So, in fact, at 0 seconds, upon entering the speedway, they are at the same spot. So you should get, in your quadratic, you should get an answer of 0 because they're side by side when? At 0 seconds. Right? I know that the quadratic's coming because it's Fred and Barney kind of question.
I don't know how to do a quadratic. I was never taught one.
Okay, well then I need to do that.
Yeah. What's a zero question?
A 0 question.
Sorry, where did you get zero? Because I'm sort of beside each other.
They're beside each other as the one car, right? Here's the racetrack, right? Here's the car that's doing 70, the black car, and the red car zips in there, right?
Oh, okay.
At that instant, they are side by side. That is t is equal to 0. You said the t was 4, Mr. Bennett. That's a different time. Hang on. That's the time it takes for the red car to do what? Get onto the track. Okay, so that's a little twist to the situation. Right? But t is 0 is going to be this time here. Okay, Brady, what's up? Okay. If the entering car maintains its acceleration, what does that mean? I mean, the car A, the red car, is an acceleration of 6 until the question's done. Right? How much time is required for it to catch the other car? Okay. So. Should I just call them car 1 and car 2? Guy 1, guy 2. G1, G2?
D1.
Drive. Well, D is, yeah, I don't like D.
D1,
We'll call them C. Well, because D, displacement distance, right? It's going to make things messy. You're good? Okay, I'm going to call it car 1 and car 2. So, car 1, car 2.
So wrong.
Okay? It's okay if you use the wrong letter. I'm waiting for you to get that focus. Okay. All right. So, what do I need to know to begin with, do you think? Like car 1's initial velocity. Now, car 1's initial velocity is 0, but what Dan's referring to is his initial velocity once he gets to the racetrack. So that's kind of a pre-question almost that you got to do here, right? So how are we going to find that out? Well, his acceleration is 6, and it happens after 4 seconds. So we're going to say, I'm just going to put the car one here. I'm going to write VF equals VI plus AT. What's his initial velocity? 0. Acceleration, 6. Time is 4 seconds. He's going 24 meters per second. Start. So it's kind of like that's the final velocity at the end of the 4-second pre-interval, right? Before he enters the racetrack. So it's kind of like the Jack in the Bus question in that there's a head start, but it's not a head start distance, it's a head start in speed, right? The bus started off at 0. And that. Okay. So, position of car 1, C1 position, is equal to its displacement. C1 position is equal to its displacement. Do I have to add any number for a head start? No, I do not. Okay, so what is its displacement? D equals VIT plus a half AT squared. Will that work? Yes? VIT plus a half AT squared. C1 position, yeah, that was about 30 seconds ago. I need you with me all the time, guys. C1 position is equal to its displacement, which is equal to VIT plus a half AT squared. What is its initial velocity? Is it the 0 or is it the 24? We're talking about the position on the racetrack, right? They just threw this little wrinkle in to sort of mix it up, make it a little bit trickier. It's the VF at the end of that pre-interval, right? So yeah, you got to be able to, right, realize that. And I get it. And the only way to get better is to practice. I did this question. It took me a while. I spent about 15 minutes working it through last night, right? But I've done countless ones of these. It takes practice. You can't jump right to the test. You've got to do the practice. Okay, initial velocity, 24. Do I know the time? In fact, that's what I'm trying to find out, right? Trying to find how much time is required for it to catch the other car. What about the 4 seconds? Okay, that's gone. That's the first part, right? Gone. So it's going to be 24t plus 1/2. What's car 1's acceleration? 6t squared. And we can simplify this down to 24t plus 3t squared. Car 1's position is defined to be, it's expressed as 24t plus 3t squared. Okay? We have to do the same thing for car 2. Okay, what's car 2 doing, Brady? Accelerating or traveling at a constant velocity?
Constant.
Constant what? Yeah, constant 70, right? Okay, so C2 position is equal to velocity multiplied by time. Why do I use that one? Constant velocity. There's no acceleration. If you want, you could write VIT plus a half AT squared. What's the acceleration? 0. What's the VI? 70. Does it stay the same? Uh-huh. These are the same thing, aren't they? So C2's position is going to be 70t. Right? Okay. When do they catch each other? When their positions are equal to each other. So what do? Make them equal to each other. C1 position has to equal C2 position. Set them equal. So in other words, 24t plus 3t squared is equal to 70t. Now this looks a little bit different than the other ones we've done because either there's been a 0 or there's a number, but the thing that's different here is that there's more than one t. No problem. About grade 9, they teach you how to collect like terms. Okay? Most everyone wants the t squared to be positive, so we're going to leave everything on the left. So it's going to be 3t squared. And I'm going to bring that 70t over, and it's going to become minus, so 24t minus 70t. Right? Yeah. Okay. We have a quadratic equation to solve. Okay? I'm going to do it two ways. Because right away I see that there is no, there's that ax squared plus bx plus c. There's no c. It means it's 0. You can still plug it into the quadratic formula, and I'm going to do that because I want to go through quadratic formula with people, but it means that you can factor it. You can factor it, right? It means that you can do this. You can take a t out when there's that, yeah. You can factor out a t out of each one, and you end up with 3t minus 46 is equal to 0. You've all seen that type of thing before? I think it's about grade 10, I think. Okay? I know that factoring is taught. Okay, so now what does this mean? It means we have two things. Either the t is equal to 0, which is what I said right at the start, right? Remember I said they're going to be side by side? So I already know that I'm on the right track, right? When there's no head start, that means there's going to be no c. I knew ahead of time there was going to be no c. How come? Because I've done lots of these, and you will eventually know too. Okay, so this means that either t is equal to 0, or 3t minus 46 is equal to 0. Can you solve that? I really hope so. You almost need to be able to just write the answer there, you guys. What's it going to be? 46 goes to the other side, divide by 3. It's going to be 46 over 3, which is 15.3 seconds. Now stop and think. Is that a reasonable amount of time given this what we know here? The one car is going 70, not kilometers an hour, meters per second. The other one is accelerating at 6 meters per second squared. It's already going 24 meters per second. After 15 seconds, what's 15 times that 6? Like 90, right? It's going to be going like well over 90 meters per second when it catches him. Okay, is that reasonable? Yeah, these are race cars. Yeah, it's ballpark, right? If you got 247 seconds, that doesn't make any sense. If you got minus, that doesn't make any sense. If you got 2 seconds, that doesn't make any sense, right? Stop thinking about it. Okay, so there's that. Now, if you were to do it by quadratic, how would you do it? Okay, so the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a, which is might as well be Chinese if you don't understand. Right? Minus b plus or minus b squared minus 4ac all over 2a. When the equation is ax squared plus bx plus c. Do I have a c?
No.
0. Okay? Anytime you've got an equation, ax squared plus b, so you've got it, like here it is here, they got 3t squared minus 46t. So this is like at squared plus bt plus c, but there's no c, right? So what is my a? 3. What is my b? Minus 46. Okay, so it's going to be, pardon me? Well, It's minus 46, so minus b, minus a minus 46. You don't need a calculator for that. 46 plus or minus square root b squared, 46 squared, minus 4. The a is 3. And the c is
0.
which means,
It's all 0.
well, that all is.
Why isn't it minus 46 squared in the? Because you can't square one.
It should actually be. It should really be.
Well, does that here?
Nope, doesn't matter. Squaring, right?
Squaring it anyway.
Squaring, doesn't matter.
Positive anyway.
True that,
Yeah.
but-
You can square a negative. You can't take the square root of a negative.
If we put just 46, we get it.
I'm not even going to look at that grid.
Okay, good.
I will look at the bottom and see if the answer matches. If it doesn't, I'll try to find it in about 8 seconds. And if I can't find it after 8 seconds,
So we could do it totally wrong, get the right answer, and then boom.
You forgot all over 2A.
yeah.
Everything else is there.
A was 3. So x is equal to 46 plus or minus the square root of 46. Actually, not the square root of 46, the square root of 46 squared. Do I even need a calculator for that? Why am I picking up a calculator? What's the square root of 46 squared? All over 6. Okay, now, you got to do both. 46 minus 46? Is that a big surprise?
No.
Shouldn't be. 46 plus 46 is 120, no, 80, 92. 92 divided by 6. (46 plus 46 equals divided by 6. Right? Are we good there? Yeah? Okay. So it takes 15.6 seconds to catch him. Now, we also have to find out how far has the other car traveled during the time calculated in part A. How far has the other car traveled during that time? The other car would be the one that's going 70, right? That's what the other car is. Would it not be the same distance? Would it not be, both cars would have to travel the same distance, would they not? They start out side by side and they end up 15 seconds later side by side. Right? It would be the same, I think. How far has the other car traveled? So, we need a displacement. I know the time. Oh, hey, but isn't it just like 70 times t?
What's the question? Or you guys,
How far has the other car traveled during the time calculated?
that's just 70.
That's
What's
all
the
it
other
is.
car?
The other car is the one that was already going 70.
Okay.
Right? So displacement of car 2 is v bar times t, 70 times 15.3.
Wow, that one was so much easier. I felt more.
What makes this, well, I was going to say, what makes this one harder?
You have to, no, I like the track on the track.
Oh, well, yeah. I don't know. I mean, I could ask, how fast is it going, right? You're trying to find VF equals VI plus AT. It'd be 24 plus 6 times the 15.3, right?
So that's how fast. Yeah.
How fast? The final velocity at the end of that interval, right? And yeah, you get the final velocity. It's at the end of the time we're talking about. Okay, no, what makes this one a little bit harder is this little bit here, right?
It's a lot of steps.
Yeah, it is. This is hard. It takes practice. You can't go from walking in the door to knowing how to do it in 20 seconds. It doesn't work.
Any questions?
It's like running a marathon.
Did the whole page, Chris. Yeah.
You gotta practice. Okay.